All right, we're going to find the area of regular polygons, and in this case, I'm just going to go over what's in the book. If it has n sides, n can be subdivided into congruent triangles, and the way we do that is we take 360 degrees around the center, which is a circle, and we divide that by n. And we're going to do this for a nonagon, so we're going to do this for, in a few minutes, for a polygon with 9 sides. But looking at this one, this has 6 sides, and when you do that, I'm sorry, it has 10. This one has 10. We do 360 divided by 10, which means there's 36 degrees in the triangle here. That means that each of these 2 little triangles are 18 degrees each. Then we are looking for the height. We have the base. We're given 8 as the base. Half of that is 4. We're looking for the area of this triangle here, and what we're going to do is use that 18 degrees by using SOHCAHTOA to find out what the height is. In this case, the tan of 18 degrees is, as it says down here, tan of 18 degrees is 4 over h, opposite over adjacent, and that would be 4 over h. We solve that, and we find the number of units that is, and then we can find the area. So h is now 12.31, and we use the height and the base to find the area of the isosceles triangle. 1/2 base times height, which is then 49 units. And then, of course, we know that there are 10 of these, and we get the entire amount of 492.42 square units. That's the area of that polygon. So let's go to the problem at hand that was on the homework, and it looks like this. We've already drawn it on a piece of paper.
How many sides?
And it's got 10 sides, I believe. And here's how it works. Well, just like what we just saw. First of all, 360 degrees divided by 10 equals 36 degrees. So each one of these triangles, as we create all these little triangles, and then, just going to sketch it out. Each one of those, okay, if we take one of those triangles, okay, and this is the apothem, that's right there, this is equal to 5. Now they've given us the height of 5. What we don't have is the base. And now we know that this right here is 36 degrees. So now one of these little guys, if we take half of that, one of those little guys is 18 degrees. And the base is still x, let's say, and this is 5. This is a perpendicular. All right? So there you go. That's 18 degrees. Now, we use our SOHCAHTOA, remember SOHCAHTOA, to solve this. It was easier before when we used our 30, 60, 90 degrees, but with SOHCAHTOA, we know that we have the opposite over the adjacent, right? We have the height, which is 5. Opposite over adjacent would be tan. So we've got tan of 18 degrees equals opposite over adjacent, okay? So as we were saying, SOHCAHTOA gives us tan of 18 is opposite over adjacent. We write tan of 18 is opposite over adjacent. Tan of 18 in this case, we do already have the opposite, x over 5. We're given the adjacent, and we're looking for the opposite. So tan of 18 let's see, it's equal to, anybody have that? Yeah, please go ahead. Yeah, find tan of 18. But we're going to go ahead and solve this. It's going to be 5 times tan of 18.
Somebody do tan. Somebody do tan.
And that equals x. So all we
tan
really
of 18 is 0.3249.
Okay, then 3249. Then multiply that by 5. What do you get? 5 times
1.6245.
Okay, that's good enough. And there it is. That's our x value, which is the base of one of those little triangles. And then we've got to find the area of one of those triangles. We're going to go to 1/2 base times height. And we now know the base is equal to 1/2. The base is equal to 1.624. We'll put 1.62. The height was given as 5. And if you could go ahead and calculate that, that'd be amazing.
Wait, what?
If you can calculate 1.62 times 5 and then divide it by 2. And remember, for this, we're calculating just one of these little triangles, okay? Not the whole thing.
4.05.
Okay, so that's 4.05. Now we have that. We're going to double that to get one of these triangles, so that's 2 times 4.05, which I think I can handle, at 8.1, right? That right here is going to be the area of one of these triangles, and there are 10 of those. That was our original. See how we took 360 degrees divided by 10 isosceles triangles? And this is 10-sided, 10 triangles, and we get 10 times 8.1, which is equal to 81. That's the area of the decagon is 10 times 8.1, and there you go, there you have it. So this example, when we create these isosceles triangles by dividing it to the number of sides, we find the degrees. We've got half of that to find this right triangle, the area of that, and then we use SOHCAHTOA, our trigonometry ratios, to be able to get the missing, in this case this was the base, sometimes you're missing the height. We find that, and then we can use that in our area formula, 1/2 base times height, to find the area of the little triangle, which is 18 degrees. Then we double it to find the area of the bigger one, and then we multiply that by the number of sides, which is 10, and we got the area of the entire thing. All right, thanks for listening. Thanks for watching. Any questions?
Yes.
Yes, questions.
Why do you divide by half if you're going to multiply 2 by 2 in the next one? Couldn't you just not multiply?
Well, we're going to stick. It's a good point, but the thing is, we're going to stick with the formulas. Otherwise, everybody's going to get confused. This is the formula for area, and we're going to stick with that. So otherwise, no one would know what we're doing. So that's why. Yes.
How did you get 360 over 10?
Well, because there are 10 sides, and it's 360 degrees around the. This is a circle around the. If you go around the entire. If you start here and go around, it's 360 degrees.
So the top of each triangle is 36 degrees.
Exactly. That's why we had 36 degrees here. See that arrow? 36 degrees. And that gets cut in half, and that's why we have 18 for the half side.